we're doubly pleased to have Ben Jones because not only is he a member of the Falmouth family, but he's an economist. And economists have been scarce in the Falmouth Forum. It's a very interesting discipline, but when I was dean of the faculty at Amherst, I felt it was the only discipline that felt it could solve problems by itself. I think they've learned. Dan is an associate professor of management and strategy at the Carlton School of Management at Northwestern. Graduated from Princeton, was a Rhodes Scholar of Oxford, where he got a B.Phil in economics, and then got his Ph.D. from MIT. During his Oxford years, he spent some time as a lecturer at the Kazakhstan Institute for Management and Economic Progress. And then the following year, he was a special assistant to Larry Summers when Larry Summers, was Deputy Secretary of the Treasury in 97-98. What you have in your hand, the page that describes that, suggests that he's investigated a wide variety of subjects, and indeed he has. He's written, for instance, on collaboration in innovation, and he has collaborated in an important article for the Hamilton Project Brookings Institution on harnessing technology to improve K-12 education, arguing that a uniform standard to evaluate the effectiveness of learning technology is necessary. And that very topic was in the Times, New York Times, a couple of days ago. Because without it, people try to invest in learning technologies to find out what works and what doesn't work. Another important article that Ben wrote, made public by MIT, is Temperature Shocks and Economic Growth, in which he shows that higher temperatures have more serious and far-reaching effects in poor countries, rich countries, labor productivity, health, even political conflicts are all adversely affected by higher temperatures in poor countries. And he's also recently addressed in a different article, what do we learn from the weather? And I suspect that's going to appear in what he talks about tonight. Ben and his collaborators have examined a number of accepted propositions, asking, for instance, at what age do scientists produce great ideas? And as a gauge of that, they took the Nobel Prizes. The usually accepted rubric is that physicists receive their Nobel Prizes at a young age. While that was indeed the case in the early years of the prize, Ben and his colleagues have been able to show that since the shifts in the mean age of Nobel laureates since 1985 have increased almost 13 and a half years in physics, 10 years in chemistry, and 7 and a half years in medicine. Part of the difference in age of achievement relates to the difference between theoretical and empirical work. The theorists reach their great creative achievements almost 4.5 years ahead of the empiricists. There are multiple factors and, of course, complex reasons for this, dependent in part on the nature of the field in which the work's being done. But they've done a detailed examination that makes all this clear. He's also developed a generalized framework for human capital accounting, amplifying the role of human capital in comparisons between countries. Apparently, I say apparently because I don't know this, but apparently earlier in economics there was a dependence on wage variation as one of the keys between countries. And he and his colleagues demonstrate that wage variation is really not that important. What really is important is knowledge acquisition by skilled labor, which as a layman you think pretty obvious. Thereby increasing quality, And that's likely to be the central feature of understanding productivity differences. Ben's received many other distinctions for his work. I won't try to enumerate them all, but I'll just mention two. In 2010-11, he was a senior economist for macroeconomics for the White House Council on Economic Advisors. And in 2011, he was awarded the prize for the best academic article written by a Kellogg faculty member in 4 years. I think you'll agree he's well prepared to talk to us about the economic costs of climate change.
Well, it's a great pleasure to be here, to be in Falmouth, my hometown, to see familiar faces as well, including people that are important to me growing up, family and friends and teachers as well. And I've come tonight to talk about the economic cost of climate change. I live in Chicago now, which is a cold place. And apparently, Withdrawal is not also a cold place. I don't think I've seen Hilton on, so I know. This time of year in Chicago, I often wonder, maybe global warming isn't such a bad. Maybe you're feeling that right now yourself. But the theme of this talk will be that warming is probably, unfortunately, bad. Not only bad, but a lot worse than a lot of people have been thinking, including in policy. What I'm going to do is review a lot of the most recent literature, because there's really an explosion of research on this topic by economists that has been showing the cost of climate, not climate change, in new ways, in more rigorous ways. So the motivation for this talk are really two interrelated questions. The modern question that is on many people's minds, because of all the talk about potential global warming, is will climate change have substantial economic consequences or not? What do we know about that? Now, that's sort of a new question to economists, because we haven't been thinking about climate change for that long. That said, there's an older, more classic question, which has been in economics for a very long time, which is, can climate help explain the wealth and poverty of nations? We have very large differences in income around the world, and maybe climate has some role to play in that. What do we know about that? So, getting the answer right on the role of climate in the economy is really critical for any climate policy. And what I want to do tonight together is first say, well, how could you answer those questions? How can we, what is evidence? What is good evidence of that kind of question? And then what are our best answers heretofore based on the literature and research that's been done? I should tell you at the beginning, as it was made clear, and I want to thank Ross for a very kind introduction. I am an economist. I am not a climatologist. There are people in this room who know a lot more about climate models than I do. And as I'll make clear over the course of the talk, what I really want to focus on is not what's happening in the climate. In fact, I need to take no stand on the future path of the planet's climate. What I want to tell you about is what we know about how whatever the climate's doing affects the economy. Okay, so start with some classic views. So the idea that climate might be important for understanding the progress of economies is very old. There's, Greek, it goes back to the ancient Greeks at some level. In the Arab Empire, the Arab historian Ibn Khaldun wrote a treatise in basically saying that wealth or poverty within the Arab Empire around the Mediterranean, in his view, could be explained by the relative heat of various places, basically saying that when it's hotter, people don't work as hard. Okay? And that is actually more well known in Western thought as being associated with Montesquieu, who made a very similar point in his 1750 Spirit of Laws. Quote, famous quote from him is, "There are countries where an excess of heat enervates the body and renders men so slothful and dispirited." And the idea that maybe you felt yourself, and maybe when it's really hot out, you just don't quite feel as energetic as you might otherwise feel. He would then go on to develop a whole theory of development, which is somewhat problematic based on the idea that people in hot countries wouldn't work hard. You got this sort of, therefore you should enslave them and force them to work hard, which wasn't really the point. But so we'll leave that aside. But insight that maybe heat isn't so good for you is an old one. Fast forward to the 20th century, the early 20th century, Huntington wrote a book called Civilization and Climate. And here I show you a map that he put together based on not much empirical evidence, but such as it is. He basically said, yes, where it's hot or maybe a bit humid, that's a bad place to do work, and where it's sort of the right climate, it's kind of dry, heat, temperate climate, that's a good place to do work. So the dark areas, which happen to fall in the United States and Western Europe, are the good places, where the climate is good, and then the other places aren't so good. And so this idea, this is called, you can't read it, the distribution of human energy on the basis of climate. That's this video that's true. So again, this idea has kind of been a perennial idea in old ideas about the nature of wealth and poverty around the world. Now, fast forward more, and we can start to have data about countries. We can have progression and statistical evidence to get at these questions. And so what did that show? So the early analysis of this would be cross-country analysis, by which I mean you would get a bunch of data about every country, and you know how rich or poor they are per person. The U.S. is rich, Luxembourg is rich, the former Zaire is poor, and then you get data about their average temperature or some other climatic feature, and you would see if these are related. And if you do that, in fact, you find that when you average across the world, a country that is on average, over the course of a year, 1 degree centigrade warmer is in fact on average 8.5% poorer per person, okay? Which is a pretty big difference because if you go from hot to cold countries, you're traversing quite a lot of temperature difference on average, and that's going to add up 8.5% per degree, and so you're going to explain quite a lot of variation across countries. In fact, with temperature alone, you can explain about 23% of the variation across countries. But that's just a correlation. Okay? So the problem with this kind of analysis is that it might just be spurious. Right? So does that mean that just because they're correlated does not necessarily mean that temperature causes poverty? Maybe it's that poor countries have bad institutions. They sort of have a lot of corruption or a lot of autocracy or weak property rights or all sorts of other problems. Or maybe it's infectious disease and it's not really temperature per se, it's still somehow geographic. And those other features could be explaining why they're rich or poor, and it just happens to be associated with being hot or cold. That doesn't really actually matter. Right? In the same sense that if a rooster crows, the sun will come up shortly thereafter about the same time. But that doesn't cause the sun. Right? So you have to be very careful when you see associations to make sure that you think they're actually took the rooster away and put them in a box and sun's still going to come up the next day. So a lot of people argued about this, and actually this was sort of a big debate. So Jeff Sachs, for example, is an economist who's associated with thinking that geographic factors, including climate, might be very important to understanding the wealth and poverty of nations. But in fact, others have said this is all spurious, and more prominent modern views in economic development have really moved away from geography as sort of a source of explanation, and really thought it was much more about historical inheritances from colonialism or weak property rights or more institutional, what we could call institutional features. So this was sort of, this was out there and has been sort of rejected. Not rejected, but not agreed upon, let's say. Now, moving a little forward, you could also look at subnational analysis. So if you really believe that it's just a spurious association, you could say, okay, well, so I can't look at the cross-country data, but what about if I look within a country? So for example, with some co-authors, I've done some work which looks at, are hotter parts of countries poorer than colder parts of the same country? Okay? So for example, one of our papers, we took town level, municipal level data, state level data, state province level data for 12 countries in the Americas, where we can do average income per person by city or by state, okay? And we can look at the difference in temperature or other geographic factors. And if you do that, you actually find that within the same country, the municipalities that are 1 degree Celsius warmer are on average about 2% poorer per person. So this is a much milder effect than across country, looking across the globe, looking across countries, but it's still pretty big and interesting. So I was quite surprised when we saw this. And that suggests to me that maybe there really is something to this temperature, because this is a little part of to say that this would also be true by chance, and that there would be a relationship between So, what I really want to talk about tonight is a whole new style of evidence, okay, which tries to think of a different experiment. Again, using data we can observe about how economic performance might be related to various climatic variables. And of course, if you think, what would be the ideal experiment? At some level, what I would like to do is take a country, and I'd like to observe it for a while at a certain temperature. I'd like to go back in time, turn on the thermostat, and observe that country again. And I'd maybe go back and turn down the thermostat, and I would kind of experimentally play around with the temperature of the country, and I'd observe the same exact situation through history many times, and I would just randomly change the temperature. And of course, we can't do that, okay? That's sort of the ideal. If you were in a lab and you could really kind of experiment in a lab. We have never had that. Economists don't have the luxury. We're challenged by that. We sometimes have the luxury, but we don't usually have the luxury of being able to run those kinds of experiments, especially with this kind of question. So what can you do? Well, sort of the natural experiment version of that is the following. A given country experiences different weather in different years. And so this has been a cold winter. Okay, and this part of the country has been a warm winter other places. So you could say, all right, well, in 1984, I've got this country, and it had a certain temperature. And then in 1985, that country had a different temperature. And in 1986, it had a different temperature again. And I could say, all right, well, this temperature is going up and down, and it's kind of random. You have hot years, you have cold years. Those aren't really caused by anything people are doing per se, at least over the short run. Maybe over the very long run it is, but you just get kind of different draw on the random temperature. It rains more one year than the next, hotter one year than the next. And ask, okay, well, within a place, over time, do I see any relationship between hotter years than normal, having any kind of unusual economic or political, economic or health or any kind of implication? And if you get all the places in the world, or you get every place, you can say, all right, they're all having temperature going up and down, or precipitation going up and down, and I collect all that data, maybe now I can say something that's a lot more positive. I can treat these changes randomly year to year, or one period to the next, kind of randomly being shaken around, and then say, all right, so what happens? What happens to this? Okay? And there's been a really big literature that's developed really in the last 5+ years that has looked at this question. Frost alluded to an article I wrote last summer called What Do We Learn from the Weather? And it was a review article of this literature. And so what I want to do now for a little while is just see what we learned when you put all that literature together. And of course, everything is still in progress, and all these answers are not totally clear, and I'll give you some big caveats as we go later into the talk tonight. But I want to say that we've actually learned quite a lot in some dimensions. I want to review that for you. In fact, this was written, we wrote most of it last summer. One of my co-authors, Ben Olkin, was actually sitting in an office at MBL while we were doing some history of MBL in this paper. Yeah. Okay, so the idea here is now use temperature changes. And of course, I said why we should do that, and I said that's because you can get towards causation. You can get towards how a temperature variable bouncing around and actually explains the outcome you care about. The other thing that's kind of nice about it is if you start to think about climate change, we're actually talking about temperature changes. So although this is a very short one, different from a long run, I'll come to that later, it is actually change. So we can begin to get some sense of how places react to change, not just sort of a given fixed temperature or climatic setting. All right. So we're going to exploit temperature changes within a place, typically a country, and ask what happens to economic outcomes of interest. I'll look at a bunch. But for example, to start off, when a country is hotter than usual, do we see any effect on its national output? This should allow positive interpretation as long as temperature is kind of moving around relatively randomly from year to year. Limitations I've been sort of alluding to without being specific is that this is short-run fluctuations, which gives us causation. But in the longer run, societies may respond somewhat differently. Like if you have a surprise year like you have here, it was full this year, certain things might kind of not go well. But if you knew that every winter was going to be like this, you might put in place some kinds of strategies that would make it easier to deal with. In fact, you might leave. We're going to come to that as well. I was just supposed to give a talk at Duke last week, 2 weeks ago, and it was canceled the night before I went on the way to the airport because it snowed in Durham, 1 inch. doesn't snow, so there's no adaptation, so it becomes very costly. Another way of saying that is that in the short run, when something unusual happens, you make a kind of not the same response as you knew it was coming. Okay, so I'll come back to that a bit later. And that's why one limitation getting from this literature to the long-run effects of any climate change. All right, so here's some picture to show you the world since 1950. Every country appears once here, a little three-letter code. On the horizontal axis, over here towards me, is rich countries per person. So that would be Luxembourg, the United States, Norway. And going to the other end over there are poor countries, countries that are poor per person. And then you have average temperature on the vertical axis. So up there is hot, and down here is cold. And you can see that actually, if you ran a line, it kind of would slope down. Right? So again, countries that tend to be richer tend to be colder. Okay? Or countries that are hotter tend to be poorer. There are some exceptions. There are countries that are rich and hot. Those are Gulf states that have a lot of oil. Yeah. ERN is, I guess, Bahrain, KWD is Kuwait. If you go over there, there are very few countries that are actually very poor, but also cold. That's pretty rare. Most poor countries are hot, very hot. The BTN is Bhutan, that's another unusual place. MNG is Mongolia, also a fairly unusual place. Most cold places are relatively rich. Most hot places are relatively poor. Now, what you're also seeing for every country, however, is if you see it as sort of a gray line vertically next to every country. And that tells you how much the temperature has varied. That's the average temperature every year. You can see that some countries have years that are 1, 2, 3 degrees Celsius warmer on average than other years. Okay? When you think about global warming, for example, you think about warming maybe 3 degrees Celsius over the 21st century. So actually there has been variation annually at least on in degrees Celsius from one country to one year to the next in a lot of countries. It is at some level on par with some of the variation we might see in warming potentially over the next 50 years, if not a bit longer. And what we want to do is exploit that some countries have hotter, cold years and ask when they were hotter, how did their GDP do? How did GDP seen the measure of income or income per person? And when they were colder, how did they do? So what do you find? So this is a result on income per person, which is a simple measure of economic prosperity. So you find that when a poor country is 1 degree centigrade warmer than usual in a given year, its growth rate of output per capita is 1 percentage point lower. Okay? So that's, like that would be the U.S. would be going from, say, 3% growth per person to 2% growth per person, which is a pretty big difference. Okay? That's actually a very, very big effect. The interesting thing about it as well is it's not like you have a hot year and you have lower output, and next year you're kind of back to normal and output pops back up. What we actually see is that if you lose that output in a hot year, you don't get it back. You lose it permanently. So it looks like it's actually affecting the growth rate of half, the overall long-run path of these economies. By contrast, if you look at a rich country, noisier, you don't really see any effect. So when a rich country like the U.S. is 1 degree centigrade warmer in a given year, no obvious relationship with GDP whatsoever. Okay. So there's a temperature effect that's really closely associated with being poor. It doesn't seem like it's necessarily associated with being hot, per se, or agricultural. That's a bit hard to separate because poor countries are typically hot and agricultural. It's a little bit hard to separate whether it's that you're poor, is it that you're hot, and an extra degree warming when you're already hot is really devastating, or that you're sort of, say, very agricultural, so you're very sensitive to climate change. You sort of tell all sorts of these stories, and they're going to sort of relate. Okay. I want to point out again that that's a very big effect. Because let's say that if you believe that you turned up the thermostat 1 degree C, and poor countries in the long run grew slower, so that their path is like this instead of like that. The place you end up, if you're going to 1 percentage point less per year, after 50 years, 60 years, 70 years, you're at a lot poorer per person than you would otherwise. So if that would hold up over a longer period of time, it would just very devastating effect on poor countries. Okay, now, I've been talking about GDP so far. I looked at cross-sections of who was rich and poor in the world compared to temperature. I just looked at whether you grow faster or slower depending on temperature. I'm using gross domestic product, or really GDP per capita, income per person. Why would I do that? Well, that's in some ways a nice place to start, because you might think that the relationship between climate and the economy in general is actually really complicated. And I'll give you some evidence in a second to suggest that it is complicated. So here's my simple diagram, but that's climate. Over here is GDP. And in the middle, climate might have implications for agriculture, energy use, forestry, fisheries, labor productivity. Maybe we're just all productive when it's hot. Kind of like Montesquieu said, it could have health effects, it could have effects on crime or conflict. There are all these different kinds of effects, and all those effects themselves might interact with each other. Right? So it could be that there's an effect on agriculture, and because there's an effect on agriculture, people leave agriculture and go into construction. And they go into construction, so agriculture goes down, and construction goes up. And so what's the overall effect on people in the economy? Or maybe it's that it has a negative effect on agriculture, but then because we didn't make any pomegranates, then just the whole pomegranate juice factory shut down. And so it has a negative effect on industry. But how would all these things interact? Okay? And then maybe it causes political problems and political conflict, and that starts spilling out in different directions. So one reason to look at just output and just sort of jump from climate over all the interactions, all the possible channels, and go right to kind of GDP, is because GDP gives you kind of a net effect. Right? So once you, whatever those channels are, how they all interact, at the end of the day, it has some average effect on output per person. And you just sort of ignore the complexity in there. Okay? And that's useful because it gives you some sense of whether there is an overall net effect, not something we care about as a metric of economic prosperity. It's also the case that because all those interaction effects are possible, and we have no idea how they might interact, you couldn't otherwise calculate that effect. It's not credible. Right? So this is kind of an empirical leap from temperature shaking around over here to GDP shaking around over here. I'm going to be kind of agnostic about what's happening. Okay? So that's why you might do that. But that has its own limitation. One limitation is because if you wanted to intervene in that economy in some way to prevent and de-link climate from GDP, these bad effects we see in poor countries today, how you would intervene would probably depend a lot on which channels you think are operating. Right? So for example, if I thought that it was all becoming by agriculture, then I might say, all right, I need to help workers with farmers with irrigation, or help them select new crops that are more resistant to drought or temperature, or change planting seasons. I might have a whole bunch of interventions that might de-link climate from the economy and save a lot of people a lot of pain. But what if it was actually, say, industrial, or it was conflict? If it was conflict or security issues, then I wouldn't want to do all the crop stuff. I don't want to invest in security and sort of stability, or maybe better political institutions to help people manage conflict or something like that. So it could be a very different kind of intervention. So partly with that motivation in mind, we want to dig down and understand what's really going on that would get to this GDP effect. We want to analyze by sector. Now, a lot of people have analyzed this by sector. Again, what I'm doing here is I'm going to review some evidence about how temperature changes, but maybe some other changes, affect various aspects of the economy beneath GDP. And I want to do that, and all these studies I'm talking about are using the same method. So it's always saying, well, it's either hotter or colder than it usually is in this place, and sort of what do we see happening? Okay? Which, again, we think is sort of the best way to identify what it might actually be doing with some kind of sense of causation. So, agriculture, what do we seem to see? Well, there's a lot of work on this. It seems that higher temperatures do cause large agricultural output declines, especially at extreme. It depends on the crop. The crops have a certain threshold. If you have days above that temperature threshold, really bad things start to happen. Okay? You can sort of irrigate around that for some types of things, but not for others. But there's a bunch of literature that finds, and this is again not just, I should say, this isn't just in poor countries. A lot of studies in agriculture find big negative effects in the U.S. as well of extreme heat days on farming output. One of the reasons you could have these big effects on farming in the U.S. and still not see a GDP effect in the U.S. is because farming is actually a very small part of American a few percent of GDP. So in some ways we're insured against that because it's not as important a channel in the U.S., although it's certainly very important to farming states. There's quite a lot of evidence that people will leave. Before I go into whether or not you might leave, but in fact you see a lot of out-migration from farming areas when climate is negative for productivity. There's studies that go back to the Dust Bowl in the United States in the 30s, you're seeing a lot of out-migration, but even in more modern context, you'll see especially young people leaving farming communities due to climate-related shocks to the agricultural action. I'll come to conflict in a few minutes, but when you get migratory responses, of course, that stirs up the possibility of conflict. One thing when people can sort of country, and we have well-functioning systems for that. But when there's a cross-border migration, you have environmental catastrophe on one side of the border. It's something that's very well studied yet, but you can imagine sort of environmental challenges in farming leading to exodus to the neighboring countries. Actually, there's a lot of evidence, for example, that in Mexico, when there is negative climate shocks to agriculture in rural Mexico, you see more migration to the United States. Okay. Industrial output. Now, I think agriculture, to me, that was totally unsurprising. So, I mean, these results didn't surprise me at all, because we think climate is such an obviously important input into farming. Anyone sort of knows that, whether it really matters to farmers. Industrial output, however, turns out to have big negative effects. So in poor countries, we see that industrial output actually declines about 2% per degree Celsius. Okay? There's been in a few studies. And in fact, those effects are actually as big as the agricultural effects in poor countries. So it's not simply an agriculture story. It looks like it's actually an incidental story that also involves industrial output. Here's some data on that. One of my papers that looks at exports from poor countries. You can get data by industrial class. So at the top there, I've got photo equipment. The next one is dairy products and eggs, and leather, and footwear, etc. And you can look at exports from poor countries to rich countries. With data collected in the rich countries, we believe the data pretty well. We know it's collected by U.S. customs officials, for example. And we can see that when those poor countries have hot years, you see big declines in their exports of these products. Okay? And you can see, if you look at some of these are agricultural, but a lot of them are not. Okay? In fact, if you look at all the different product codes at this level, about a third of them show very large negative effects in warm years in their exports. It's mostly light industry and agricultural, not heavy industry. So puzzling about that, how would that happen? It sort of leads back to Montesquieu. One possible explanation is that it's because it's hot and people are just less productive. It's hard working outside. It's hard to get a sweatshop. We're really sweating now. It's really hot. There's no air conditioning, and people are just not as productive. Okay? So it turns out that there's actually a lot of evidence for that as well. So in this actually literature, some of it goes way back because there's a whole series of people who have studied sort of industrial productivity and wondered sort of what the right climate should be in your factory to get your workers in the U.S., for example, to be more productive. It turns out in this literature, at around about 25 degrees Celsius, when you start adding each degree Celsius, you see about a 2% decline in performance across various cognitive and physical measures. And that's based on lab experiments with workers being assigned to rooms at different temperatures, or even students who are taking math tests in rooms at different ambient temperatures, and you see performance decline at high heat. Field experiments. This study here is one of call centers, where people who answer your service calls. It's hot. Well, we know you more, because it turns out that when it's hot, they do a very good job. It's also true in population surveys. So you can take data about U.S. workers and their time use over the course of a big data set and relate it to climate measures, weather measures. And you find that people in outdoor work, not indoor, but in outdoor work in the U.S. work a lot less and get a lot less done on very extreme days. What's also interesting about that number is, 1 degree Celsius, 2% decline in performance. If you look at the industrial output, 1 degree Celsius, 2% decline in industrial output. Numbers are really similar. That's sort of what follows through into GDP, more or less as well. So it's kind of, there's sort of a consonance between all these various different kinds of studies at different levels of data and aggregation. And Montesquieu might have been had something going there. And even Muldoon before him about just, people who are not. A couple other aspects as well. Health. We can care about health totally independently of any other kind of economic measure. Mortality rates do go up very clearly with extreme heat. You read about that in the newspaper sometimes. If you remember heat wave, you see this happen. Also extreme cold. It's actually interesting in northern U.S. states, when there is extreme heat, people die at much higher rates. But when there's extreme cold, they don't. And in southern U.S. states, when there's extreme heat, they don't die. And when there's extreme cold, they do. Maybe it's because we have heating in the north. They have fair so we can have indoor temperatures that we can cut off extreme cold, but we can't get rid of extreme heat very easily once we go into air conditioning. The north and the south, the other way around. The U.S. mortality goes to about 0.5%, the rate in a month per day, about 90 degrees Fahrenheit. In India today, that effect is about 5 times larger in one study. The best study on that. What's also interesting is that the U.S. rate has fallen steadily since 1960. In fact, if you go back to before 1960, the mortality effect of really hot days in the U.S. was like it is in India today. But we've kind of steadily decreased, which is coincident, incidentally, with the spread of air conditioning. So if you, I mean, it's a little silly. I sometimes think how interesting is air conditioning really, but it turns out that maybe air conditioning is really, really important, not just for health, but also for industrial productivity. And you obviously can't air condition a field for agriculture, but when you're going to indoor work, perhaps it's actually an essential mitigation mechanism from an economic perspective from some of the costs, and the very large costs that may come from any warming in the world. Last, but certainly not least, are crime and conflict. There's a really beautiful paper that was in Science in 2013, which went about all the studies that have used data like the kind that have hotter, colder times and periods, and what can we detect across all sorts of different kinds of crime and conflict measures. And when you aggregate it all together in this big meta-analysis, you find very consistently that there's a pretty big effect of both heat and precipitation in more complicated ways. Let's just take heat, for example, of higher heat on more crime and higher heat on more intergroup conflict, by which I would mean political coups or civil wars or cross-state conflict. So I'll give you two examples. On the left, that's violent personal crime in the U.S., which would include assault, murder, manslaughter, also sexual assault. By week, okay? Brian Jacob and co-authors. So this is by jurisdiction by week. So take a jurisdiction, take felons, okay? And you have every week of the year, right? And let's say that it was May, it's the third week of May. And they're saying, all right, well, if it's unusually hot in the third week of May, you see more violent crime in your jurisdiction. And when it's unusually cold in the third week of May, you see unusually low violent crime in your jurisdiction. And you can see that upward sloping line. The hotter you go, if you're unusually hot in that week, you see an unusually large increase in violent crime. Okay? This is an old crime lecture. This has been established over and over again. So people commit crimes when they're hot. In fact, it's even the case that Major League Baseball players are more likely to hit the opposing batter than usually. The neurological or psychological, whatever is going on in this process is not entirely clear. There's some ideas, or I'm sure some real scientists in the audience can laugh at me, but there's some neurotransmitter, I think might be called paroxetine, that might be related to inhibiting aggression, and maybe it diminishes with high heat. There's maybe some kind of physiological basis for this, but regardless of whatever the underlying mechanism is, it's very clear in the data that there's this relationship between aggression, personal aggression, and heat. Another one's been very clear. One of the early studies is riots. Far more has been surprising. Riots happen on hot summer nights or hot summer days. They don't happen in cold weather. Unusually hot weather, much higher incidence of riots, for example, in the United States. That's personal conflict, person to person. This would be civil or intergroup conflict. So this is just another study of political and intergroup conflict in East Africa. And again, you see, going this way is unusually hot versus unusually cold at that time of year in that place. And this is sort of more, you're seeing upward sloping lines. You're seeing more civil war, civil conflict under higher temperatures. This overall, I'm giving you two examples. This paper puts 60 different studies together and kind of averages across them all. You see a really consistent relationship between crime and conflict. Which, of course, like health, you might care about crime and conflict independently of how you care about economic outcomes. It's also the case that health outcomes, crime and conflict outcomes, feed back onto the economy and have civil war, of course, and very negative effects on GDP or other economic outcomes. Okay, so that was a brief tour of the world there on a lot of this new literature. And what you can see is really rather systematic findings where there are really large, surprisingly large often effects of kind of these temperature changes on all sorts of human behavior. And most of those studies have been done in the last 5 or 6 years. Okay, but here's the problem. So if you wanted to get the climate change, that could all be very interesting just because you care about climate and you care about policies that might deal with hot years or cold years and forget climate change. You just want to know if we should have policies that protect people health-wise or crime-wise or conflict-wise from changes in weather and climate from year to year. But of course, a big motivation question in a lot of this literature and for a lot of people is what happens if the world's getting a lot warmer? Can these results inform them? And the answer is they're helpful, very helpful compared to the prior literature because I think they show us that there are these causative pathways that we couldn't really clearly identify before across a rich set of outcomes. They're less helpful in the sense that the long run and the short run are pretty different, right? Because over the long run, you might adapt, and you might, I mentioned adaptation before, like my comic, be able to survive 1 inch of longer run changes. Let's not look at year to year. Let's look at like 10 years to 10 years, or 20 years to 20 years. And we're limited a bit because we have to look backwards to get the data. We can only go back so far. But a couple of studies have done this. One of my studies looks at GDP. If you go over, we can look from, say, 1970 to 1985, sort of 15 years, and then look at 1985 to 2000. And now for the countries that kind of got warmer over a 15-year basis, they see a lower growth. And you see actually the same effect. In fact, the countries that, poor countries that got more warm over 15 years, see very large negative effect on their GDP. So that's just at least over what we call maybe the median run, 15 years. It's still not climate change over 50 years. But it's bridging from towards in that direction, and we see actually a pretty sustained effect. One study of U.S. agriculture looks for adaptation similarly over long periods of time. In the U.S., and sees very little evidence, in fact, of agricultural adaptation from the higher temperatures that we've experienced. So that's just two studies. This kind of study is only really now being done, so it's really too early to say. So I'd say the evidence is very thin, but so far, it seems like there's not a whole lot of adaptation across some of these methods. This is a big area for future study where a lot of new work is trying to go to kind of make that leap towards longer term. I wanted to close with a couple of comments about policy. What does this mean for policy? How do we think about any of this and what we should then do as a policy? There's a tool called integrated assessment models, which are the main workhorse for creating policy prescriptions. So if you ever read in the paper that someone said, this model said we should have a tax on carbon, gasoline, or whatever, and that tax should be $50 a ton, or $20 a ton, or $100 a ton. Those numbers are coming out of these integrated assessment models. They're a tool. What are they? It's a model. It's a model of both the economy and the climate. Climatologists say a model of the climate, a model of the economy. Okay. That tries to map future states of the world. And then try and determine, depending on how the climate and the economy are going to evolve, what would be the appropriate policy as well. Okay. So you can think of sort of three pieces. There's a climate piece, which is going to affect the economy. Okay. There's an economy piece, which is going to generate, say, greenhouse gas emissions. And those emissions are going to somehow have an effect on climate. Okay. So if you're a climatologist, you think a lot about emissions to climate. And like, what's that process? Well, how would more carbon in the atmosphere affect climate? Everything I've talked about today is about the climate to economy. That's all I've been talking about. If there's changes in the climate, for whatever reason, how would that affect the economy? Okay? So, an integrated assessment model is going to come and map the whole thing. And without, just to cut through it, a simple principle would be that the bigger the economic damages, right, from any climate change, other things equal, the more we should do now today to avoid it. Okay, so the idea of taxing gasoline today is to sort of prevent some of the climate change for some reason, perhaps because it would otherwise cause a lot of economic damage eventually, kill people or other great conflict. Okay. So, simple rubric, it obviously matters in these models to understand in that climate to economy link, how strong is that link? How much does climate affect the economy? Does it really matter? All right, so then the question is, all right, so these integrated assessment models, how do they actually model the economic damage? And here I want to just point out, if I can, I'll beat up a little bit on these models. Traditionally, the model of climate to economy is not very good. So here's the Stern report. I'll use a couple of other people to make this point. The Stern report is a very important international report trying to tell us what the right way to tax carbon would be based on all the outputs of various integrated assessment models that are out there. And even Stern's report says such models must make drastic, often heroic simplifications along all stages of the climate change chain. In other words, there's a lot of sort of focus going on in these models, right, if you look at them closely. Then he says, nevertheless, the IAMs remain the best tool available for estimating aggregate quantitative global costs and risks of climate change. Because in other words, what else are you going to do? You need some integrated model of climate and economy to make any claim about how we should be taxing ourselves now to change climate in the future and what benefits that would bring. I wholly agree with him, because I think he's right there making kind of assumptions that have come nowhere, but also right that this is an important tool. Okay? Sort of more frank is Pindak's recent review of these models just from a year or two ago. He said, this is actually the abstract of his paper, which he is, interesting academics sort of throw bombs at each other. But this is one of the more frank, shall we say, abstract I've ever read in my life. He he wrote, these models have crucial flaws that make them close to useless as tools for policy analysis. The descriptions of the impact of climate change are completely ad hoc with no theoretical or empirical foundation. He's basically saying these models have basically just made up whatever they want about how climate affects the economy. No scientific basis for that at all, he's basically saying. The IAM-based analyses of climate policy create a perception of knowledge and precision, but that perception is illusory and misleading. This is a very harsher take on the state of affairs in this literature. What has happened now is, in the last 5 years, all this evidence about how climate might actually affect the economy that people are starting to believe, that it's not just sort of arguments about this country's poor because of climate, or is it? Right? But we actually have evidence of what happens when climate changes and what happens to all these underlying economic outcomes. Has now allowed people to go into these IAMs and sort of pull out the old sort of focus climate to economy relations and plot back in some of the facts that we've actually seen in the data. Okay? And of course, those facts themselves are uncertain. Nothing I showed you tonight is I feel 100% confident about it. The literature is still developing. But if you just to show you what happens, anytime, any press article you've ever read about what the cost of the tax on carbon should be is based on the old focus. Okay? So just in January, we have a new article in Nature Climate Change that's trying to put in these estimates about how it affects GDP, at least in the data, so it's making it up. This is measuring vertically what emissions will be in the world of carbon dioxide. Okay? And the green line is if you do nothing. Okay, so the green line is what's going to happen to emissions if you just let it go. We don't have a policy. So the red line is what the old IAM models told us we should do. In other words, we should kind of let it grow like it's going to anyway, and then it will slowly by 2060 kind of diverge and sort of get rid of it eventually by the end of the 21st century. The blue line is what you get from the same IAM. It's exactly the same model, except we just put in the actual relationship between temperature and GDP that we find. I didn't write the paper, but that is found. And you see that you would go to no emissions almost immediately. In other words, you would have a much, much, much more drastic intervention if you believe some of the scale and types of economic damages that we see in some of the recent data looking at hotter core periods in the country. Another version of this is the same thing. This is what you let the temperature do. So that's the temperature now on the vertical axis. The green line would be sort of business as usual, just let it go. You didn't know no policy. The red line is what the old traditional integrated assessment models would have said. So you would make an intervention to lower warming, but maybe not that much. And the blue line says, well, if you actually took the recent evidence, what would you do? And again, these are error bars, but you'd see that you would do a whole lot more, and you would try to limit warming actually very soon to a much lower level. Okay, so this is not really filtered into the public perception yet, but the recent literature on this, we'll see where this goes. So a fight is coming between the traditionalists and new evidence. And we'll see where that goes. But you're going to start to see, I think, in the press, wow, maybe this is a lot worse than we thought, with a bunch of caveats. So to close on that, these new implementations of these integrated assessment models are now incorporating more recent evidence on climate economy effects that I think is more credible, much more credible than the old stuff, because the old stuff wasn't credible at all. But that's not to say that the new stuff is fully credible. I think it's still a lot of uncertainty. There are deep challenges, in getting to the very long run from these shorter run effects. There are deep challenges in general of making anything about optimal policies, even if we knew the economic damages currently perfectly. There's certain philosophical problems, like should we bear a lot of cost today to prevent it 100 years from now? How do we weigh future generations' sort of happiness and welfare against our own? It's a very hard question. So there's also assumptions about that, and we could have reasonable people can't do different. And of course, for those of you who don't like economics, I've been wondering why we've been trained about economic damages. I just care about climate because I care about biodiversity, or I care about keeping the world as it is. In which case, we would have a very different philosophical approach to even thinking about, what you would be having a value function that's quite different from some of the valuations that I did for computer health. You could intersect on that stuff. But if you put it back in, GDP terms, or these terms that at least speak to Congress sometimes. Some other arguments. These new findings are going to suggest much stronger intervention. So while I think all this is very hard, I think IAMs are an essential tool, and I'm hopeful that in the next years ahead we're going to continue to fix the climate to economy piece in them, try to get tighter and tighter, and it will always be uncertain. But we can do better. And I want to also emphasize that decision making doesn't require certainty. Partly because if you listen to the public debates in government, or often surreal debates in government, it's like there either is climate change, global warming, or there is not. And if there is, we should do something something, and if there's not, I believe there's not, we should do nothing. Right? That's sort of a strange debate, right? Because who knows? It's a probability. It's a little hard to say there's no chance there's going to be one. There's probably a whole distribution of beliefs, right? And normally, like, for example, if we wouldn't decide, is your house going to have a fire and burn down in the next 5 years? You wouldn't decide based on, get fire insurance, based on, like, I believe it will not burn down. I will not buy fire. I believe it will. There's some probability. It's nice. Maybe I should buy some insurance. But really, it's much more about, we can make decisions, but we don't know everything perfectly. We can make decisions under uncertainty. We should balance the probabilities we think of various kinds of outcomes, and policy can deal with it. That shouldn't be too hard. The politics, the rhetoric on this often seems to lose sight of that. Okay, so just to summarize my talk this evening. So there's been a new approach empirically in this literature that's trying to bring more credible empirical techniques to identify causative costs of climate change in a whole bunch of different dimensions, like I reviewed for you. Basic findings here are that there are pretty big negative effects, at least in the short run, very widespread across agriculture, industrial output, labor productivity, conflict, health, and then big effects on overall GDP, at least in poor countries. They're bigger than people sort of want. Larger effects in poor countries. The caveat that I said repeatedly, I don't want to lose sight of, is that the short run to the long run is not an easy bridge to make, so it's not clear that the short run effects will obvious, even that these short run effects will persist in the long run, especially if there's substantial adaptation. With regard to policy, I closed by trying to show you a little bit about these integrated assessment models and how we make these policy determinations about how we should tax carbon. And the models that incorporate the newest evidence of these kinds of findings are basically, in a nutshell, suggesting far more aggressive interventions now than the old models would have suggested. Thank you very much. Very pleased to take questions. Yes, sir.
So early on in your talk, you presented an analysis of a change of 1 degree C in warming for the productivity of different countries. And then later on in your talk, you presented an analysis about crime and conflict that was based on deviations in temperature based on standard deviation.
Yeah.
Warmer countries, tropical countries, have much more stable climates, so they have a much smaller standard deviation in temperature. So if you redid that first analysis based on standard deviation, how would your conclusions change?
Basically, you can do it lots of ways. What do we mean by is it deviation 1 degree C? Is it a percentage deviation from the norm? Is it percent change divided by the standard deviation to give you some kind of normalization for variability? They'll tend to show similar effects. If you do what you're suggesting and try to normalize it by the underlying variance in the country, it can get a little bit noisier. You get less precision statistically in estimating the effects. The size of the effects will similar, but you'll be less confident of what they are. So that's partly because, make a slightly technical point, it's actually pretty hard to estimate. It takes a lot more data to estimate variance than it does to estimate an average. So when you add the variance into the estimate, you're increasing noise in the quality of the estimate itself. So it may be just that you're making it harder. But people have done it various ways. Most people do the linear difference. But it's, that is, let me answer this slightly more statistically. It's not obvious what you should do because it depends on your underlying model of human behavior or how the sector works. So with regard to agriculture, we have pretty clear ideas of the biological process. People look at degree days over certain thresholds and they have some sense of why that makes sense to do. With GDP, you can sort of look at it a lot of different ways. People, I would say that, I emphasize that on 1 degree C, and that's sort of what people have done as a norm. But I think you could argue reasonably a priori to do it various.
Well, when I hear the word climate change in this contemporary context, then I have to think about the rise in temperature as being a difficult, the rising global temperature is, as I understand it, creating such extreme weather as witness what's happening right now. And, the impacts of that go far beyond the simple rise in temperature in any one place. Hence, I find it very difficult to find a whole lot of application to this one factor, studying temperature, increase, decrease. It's not about that. That's not how I understand global warming. It's about systematic disruption of our whole planet.
Well, thanks for that question. I think the question is whether can you look at just temperature in isolation, or how would you measure temperature? Should you look at average temperature? We talked before about should you normalize it in some way. Another thing is you just look at extreme temperature events. So we only look at, how often you experience a day above 40 degrees C. And these have all been done. So, when it's somehow I'm giving you the findings, I'm not giving you all the whole sausage making it all behind it. You might want to look at nonlinear temperature. You might want, we always control precipitation, you can control for droughts, polar return windstorms. There's a whole lot of stuff going on in the climate. There's an interaction potential between temperature and humidity. But it does turn out, and I just wanted to synthesize and boil it down for you tonight, that actually looking at average temperature in a country over time is actually very, very predictive of negative effects. So that's just an empirical finding, which sort of tends to be true. I didn't emphasize this, but in health, it really isn't about average temperature, it's about extreme. In agriculture, it's also about extreme. So I didn't go super deep into sort of underlying weather and climate constructs. But to your broader point, I think, I get in this literature, and I'm an economist, so I try to, as a scientist, I'm going to be very skeptical all the time, and not let my priors drive my analysis. And what I try to show you tonight is sort of what the data says. I just love the data speak. I don't think this is basic. People have very different views on what they think climate change might do, and they come from all sorts of different places. But I try to show you tonight basically just an evidence-based.
Do the models, these integrated assessment models, take into consideration things like sea level rise or ocean acidification, two other big effects?
Different IAMs do different things, and I think climatologists can tell you a lot more about what aspects of the climate are being modeled. See some of those effects, for example. There are certain, we talked about, I said, short run might be different from long run. Maybe you adapt, maybe there's intensification. Another form of intensification would be that there are other kinds of effects that we just haven't seen yet, like serious sea level rise. There's nothing in the historical record recently that can say, what would the effect of that be? So if you had a view that was important, that would be an additional cost that would sort of go beyond anything we can sort of identify here. And there may be other forms of that, like some ideas about biodiversity. So that's a great question, and also a limitation. And that kind of story is probably a limitation, and the direction these are understood.
The debate we're having in Congress is not about whether there's climate change, but what is the cause. One side believes it's human activity, the other side believes it's natural cycles. So how can we come to any policy decisions if the two sides don't agree on what the cause is?
Let me make a point about that, actually. Partly I made a point about uncertainty, and so we should sort of just, people are actually going to be reasonable in policy, which is not always the case, but unfortunately, but should we just think about the distribution of possible probabilities, as opposed to sort of it is or it isn't? When people think about intervening on, well, what would a policy be? A lot of the policy is between the economy and the emissions. Right? We want to sort of somewhat change the nature of the economy to make it use less fossil fuels, right? Say, or greenhouse gases in general, thereby mean less emissions, and thereby create less climate problems. Okay? Now, if you didn't believe that emissions cause climate problems, right? So the debate here could be that climate may be changing, but maybe it's something with the sun, and it's not about fossil fuels or something. It wouldn't make a whole lot of sense to intervene on emissions, because you don't think that's the cost, right? But you still might want to intervene, because the warming climate would have all the problems that we're already talking about. Nothing in the data I showed you depends on where the climate change came from, just to get a hot years or cold years. So maybe where you want to intervene would be here. You want to just say, I don't know what's causing, I don't even get into sort of reducing fossil fuels. I might just get into here and try to deal with any emission, any climate that's happening. So that could be things like And it's actually, when you start thinking about it that way, you start to see a rather richer sort of set of policies you might consider. I don't think the policy debate currently is embracing those kinds of subtleties.
I'm not sure if you can, don't know very much about this subject, and I don't know if you can answer this, but I think it's more of a climate question. But do people understand, like, where the distribution of this climate rise or temperature rise is going to be felt mostly throughout the planet? Is it going to be evenly distributed? Is it going to be more in the Europe, United States, versus the equatorial regions? And does that have an effect on your model?
Right. It's the question about regional differences in climate change. I know it's going to get colder and cooler in New England. I hesitate to answer my question in any audience because I'm not a climatologist. In this audience, I'll only embarrass myself. I should invite someone else to this podium. I mean, broadly, my understanding is that climatology models are a lot less agreement about where regional differences than they are about sort of the global average. And my guess is that it's going to be hard. I think it's going to be very, very hard to predict. They're more in agreement on this warming, less in agreement about, say, precipitation effects or windstorm effects. But I would defer to climatology for any current or accurate summary of that. It's a great question. I don't want to say anything.
Issues of resilience and recovery in instances of natural disasters or extreme climate events, Hurricane Sandy, Hurricane Katrina. Can you see in the analyses that you do a temperature, a regional temperature difference in the recovery ability in a community that has been affected by these disasters? And is that related to something that could be much more subtle, and that is the resilience of the population, and can that be related to temperature?
Well, the question is about sort of the resilience of a economy or population to economic shocks, initial economic shocks caused by some kind of climate disturbance. So if you look at poor countries, they don't seem to recover over long periods of time from these temperature shocks. So they seem to be very unresilient. There's a broader literature that poor countries in general are much less stable, both their economies and their political system. And that shock sort of sends them in a radically different direction. So a leader dies, who's a good leader. You get a new leader, you can go from doing well in a poor country to doing very badly, or vice versa. And that never doesn't work on that. With regard to sort of climate shocks, so that's the story on temperature. You don't see a lot of resilience. You don't see a lot of effect in the rich countries, so there's nothing to do with resilience. You see one temperature. Windstorms, there's a big literature, I think, growing literature on windstorms, which are more kind of these big shocks. And they actually also tend to suggest a real lack of resilience in countries, particularly poor countries. But that's a little hard. It may be that like the Philippines just gets hit by typhoons all the time. And it may just be that they can never kind of get up off the mat and knock down. But the evidence also suggests that sort of the losses you get, like the Philippines, for example, from a negative shock from a typhoon, doesn't sort of bounce back so much. There's a study by Derek in the U.S. who looks at, say, hurricanes in the U.S., and there you see a lot more resilience. And why that is, we also see, for example, after a shock in the U.S., you're going to see a lot of federal aid flowing into that region. So part of it may be insurance from the federal government, sort of offsetting some of these things. But the evidence so far would suggest that poor countries aren't especially resilient to this environmental shock.
I understand why you use GDP, but how do you separate out what I guess I would call good GDP from bad GDP? I mean, the costs of fighting crime, disease, and war are presumably part of GDP, but presumably the part you would rather not have.
Well, it is a deep question there. The question is about, how good essentially is GDP as a metric of kind of human welfare, GDP per capita. And I would say, I'm certain we'll do this question. If you, over the long run, GDP per capita is correlated with a lot of other things you mentioned about. If you care about infant mortality, richer per capita, much lower infant mortality, longer lives, better health. They're very intimately related. So in some sense, I'm more comfortable with it. But But in the spirit of your question, especially in the storm with a shock, if I go and crush the region with a windstorm, hurricane, there's going to be a lot of construction afterwards, right? And that's going to count as positive GDP, for example. I think, while it's a good wealth metric over the long run, there are big differences in income per capita. In the short run, there's some messiness there. And I agree with the spirit of that. That said, if a windstorm was going to not bring your GDP apparently as much because there was reconstruction, that's actually kind of a downward bias of the actual effect. But you can tell sort of where it goes the other way. So it was imperfect, but I think I still think it's actually quite constructive. And one of the reasons we look at health or crime and those things separately is because you do want to step aside from the whole GDP then and look at things you might care about.
Where would geoengineering fit into the
You mean like kind of putting like reflective tinfoil in the atmosphere? Yeah, that would probably be the emissions decline. Right, so there's going to be emissions, and we're going to maybe capture it with storage, or we're going to put up mirrors to block sunlight. That would be kind of that. I mean, this is sort of the most standard. Right? We're going to limit greenhouse gas emissions themselves in the economy. You can think about that. Right? So there's a whole set of
Here, you want this? Does this work? Yes, it does. The lady back here asked a question, and about whether temperature is the right variable to be using. Another variable might be precipitation as an indicator of storms. And is it easy enough to rerun some of your correlations to see if that works?
precipitation over the other.
Storms is the, or storminess,
Windiness.
windiness,
Okay. Yeah, so basically everything I showed you is controlling for precipitation in the background. Because climate comes in packages. So we're always controlling, everyone's controlling. My work, other work is always about precipitation and control. Precipitation is a little more complicated because maybe precipitation average doesn't matter so much, and you really throw at extremes. So how do you control for it might matter? People do various things there. In general, you see, so the temperature results are robust in some, reasonable but maybe simplistic ways in controlling for precipitation. These studies almost never control for windstorms at the same time. There are separate studies that control for windstorms that also control for windstorms, and then they'll control for precipitation and temperature kind of in the background just to make sure they're getting windstorm effect. And those actually, when they do that, tend to show the same temperature effect they show. So, for example, Shank did a study of Caribbean nations affecting windstorms, controlling the temperature and precipitation, and it turns out that windstorms don't always matter that much. They matter to tourism, they matter to hospitality, those kinds of things in a big way. They actually create more construction. As we talked about a little before, temperature at the same time, higher temperatures are really hurting you and hurting industrial output. With actually very similar magnitudes to the one we featured in the talk.
So one of the interesting things about the storms we've been having in this area in Massachusetts has been, well, in particular with respect to Boston, you get a certain, maybe a threshold effect where the impact goes way up. In Minnesota, you wouldn't see the same kind of threshold. You mentioned that with respect to other phenomena as well. The economy in Boston sort of shut down.
Right. Yeah, so I think, people there's an adaptation in the system to expectations, sort of what you expect on average, but you can still get a lot of outliers like Boston doing those stuff.
There's an institutional effect too. One of the things that any of us learned from watching Wayne Laboratories fail is Ross wants me to stop, I think. Okay. They were still growing. They were still growing when they failed.
Okay.
And the issue was that they were planning for growth in excess of 20% per year. They did the planning in that way,
Right.
And when they didn't reach that number, it collapsed. So.
You're questioning whether GDP might not be the best measure?
Oh, GDP is definitely not the best measure.
So, a great point as well. GDP is a flow. It's like income per year. You could have like good income this year, but you can probably large mortgage and credit card debt. That's the easy thing. Or another example of a corporation with a lot of debt. So it's really a question about the debt to GDP level of the United States or Europe or something. And I would review do it right now. Pretty much macroeconomics that we have to very leveraged as a financial person would say. We have a lot of debt to GDP, and that raises future risk. But in normal times, I wouldn't think that would normally be
Well, there are a lot of questions left. And you can ask them to Ben in private, or you can ponder them until next year.